All right, in this lesson, we're going to continue to look at 3D figures and look at the volume of 3D figures. And just like in the last lesson, we looked at fractional dimensions, which means your length or your width or your height might have a fraction in it, which made the calculations a little bit more complicated. We're going to continue looking at this today, and we're really going to be thinking about if I can fill a space with a certain amount of small cubes, how many cubes would it take if these cubes were a little bit smaller, like if they were 1/2 by 1/2 by 1/2 instead of 1 by 1 by 1. So you'll see what I'm talking about in a little bit. So go ahead and let's quickly go over the do now answers. All right, for number 1, I just multiplied the length and the width and the height to get the number of cubes for this particular prism, so the answer to that is 84. For this one, I used that formula we talked about last week, where volume is equal to the area of the base times the height. So remember, this is like the area of one layer. This is the number of layers. So I'm calling this area of the base B. So I know the volume, I know the height, I just don't know what B is. I undo this by division, and I find out that the area of the base is equal to 11. And note that your units is inches squared because it's area. All right, so let's take a quick look at the homework answers. All right, so in this first problem, all you had to do was multiply the length and the width and the height in any order. Because we have a mixed number as our length, I had to convert that to an improper fraction. Then I multiplied across, I got 54 over 2, and then 54 divided by 2 is 27 units cubed. Then it asks, if I fill this halfway with water, how many cubic units of water did you use? So if I fill it halfway, it's going to be half of this total volume. So half of 27 is 13.5 units cubed. All right, turn the next page, and we're going to look at a different kind of problem. So here we have a rectangular prism, and it has dimensions 1 by 2, height of 3. And the first question asks, how many of these unit cubes, 1 by 1 by 1, will fit in here, okay? So I'm going to try to draw one layer. It might be a little bit messy. Here's one, and if it's 2 inches, then I can fit 2 in there. I'm going to try to draw a little dotted line. Sorry, this is pretty messy. I hope this is helpful. Let's see. So you can see that I have 2 of those 1-inch cubes on one layer, but I'm going to have 3 of those layers. So I'm going to argue that if we have 2 cubes on one layer, and if we have 3 layers, that's going to give us 6 cubes. And you can think of this as finding volume. 1 times 2 times 3, length times width times height gives us, 6 for our volume. But let's take a look at question 2. What if the cubes weren't 1 by 1 by 1? What if they were 1/2 by 1/2 by 1/2? So the question I have for you is, how many of those would fit in this space? So I'm going to have you think about that for a couple minutes and see if you can figure it out, and then we'll talk about it. So go ahead and pause the video, see if you can figure it out, and then come back and see how you did. All right, let's think about this. So if we're filling out 1/2 inch cubes, let's use that same drawing above and see if we can draw some cubes in. So we know that for this 1-inch piece, I can now fit 2 1/2-inch cubes, right? For this 2 inches, I can fit 4 of those. Right? So there's a lot going on here. So the question I have, first of all, is how many cubes in that bottom layer? And now we now have 4 along the side and 2 here, so I would argue that there's 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 cubes on the bottom layer. And then how many layers do we have? Well, we had 3, but because we're using 1/2-inch cubes, I would say now that we actually have 6. So we can fit, and I'm going to do it on here again, if we're fitting, there's one height, here's a third 1 cube, but we'll divide that in 2. Here's another one, we'll divide that in 2. So I'm arguing that we can fit 6 1/2 cubes in this height instead of 3 1-inch cubes. Again, each of these pieces is 1/2, and so we can fit twice as many. So that gives us a height of 6 cubes, and I think that means we can actually fit 48 1/2-inch cubes into that space. So again, think about that. It's a little bit tricky. I now have, twice as many on my width and twice as many on my length. That gives me 8, and I have twice as many on my height. So I'm really multiplying both the length and the width and the height by 2, because I can fit twice as many cubes in each part. All right, let's take a look at another example and see if you can see a pattern here. We had 6 1-inch cubes and 48 1/2-inch cubes. All right, same question. Let's start off with just the 1-inch. How many 1-inch cubes can we fit into this particular rectangular prism? Again, let me try to draw a couple in here. I know I can fit 2 on the 2-inch side, all right, and I can fit 3 on the 1-inch side. So that gives me 2 times 3, that gives me a bottom layer of 6. And then my height, of course, is going to be 1, 2, 3, 4, 5. I can fit, let's draw a line straight down. Not perfectly drawn, but I can fit 5 high in 5 inches. So I can put 30 cubes into that 31-inch cubes into that rectangular prism. So I'm going to ask you the same question again. How many 1/2-inch cubes will fit into the prism? So pause the video, see if you can figure that out, thinking about what we did on the last one, and come back and see how you did. All right, same thing going on here. I can fit twice as many of the 1/2-inch cubes there, and twice as many here. So instead of 2 by 3, it's now 4 by 6. So my area of the bottom layer is 24. And same thing goes with my height. I can fit twice as many cubes on the height. So this becomes 10. So my number of layers is 10. So that means I can fit 240 1/2-inch cubes into my rectangular prism. All right, so let's take a look at what we have so far. Let's go back to the problem before. Let's put that in this table. We had 6 1-inch cubes and 48 1/2-inch cubes. For this problem, we had 30 1-inch cubes and 240. And my question to you is there a pattern here? Is there some way to go from 6 to 48 and from 30 to 240? And pause the video just for a minute and see if you can figure out how you might do that. All right, did you come up with anything? Well, let me show you. If you look at both of these numbers, you're going to see that multiplying by 8 works for both of these. So that's how they compare. Multiplying by 8 is the pattern. Now, that only works for 1/2-inch cube, okay? Let me write that down. You should write this down. Only works for 1/2-inch cubes. And why is that? Well, think about these numbers again. This was doubled, this was doubled, this was doubled. So we essentially had 2 times 2 times 2 times 3 times 2 times 5. Now, this was our original 1-inch cube volume of 48, but then when we put the 1/2-inch cubes, we had 3 2's we're multiplying in. And what is 2 times 2 times 2? It's 8. All right, so that helps explain why that pattern works. All right, the next problem, I'm going to switch things up on you a little bit, so go ahead and turn to the next page. All right, I want to see if you can figure this one out on your own. So the first question's asking, how many 1-inch cubes can I fit in this space? And I think we've already done that. That's pretty easy. But now I want to know how many cubes that are 1/3 on each side. 1/3 cubes, how many of those are going to fit in this space? All right, so I'm going to pause the video and work on that and then come back and see how you did. All right, let's take a look. So we found that, like in the first problem we did, the first layer has 2 cubes in it, and there are 3 layers, so that's a total of 6 cubes, and I put that in the table here. So what about 1/3 inch cubes? Well, for a 1/3 inch cube, that means I can fit 3 of those within 1 inch. And that means I can fit 3 of them here and 3 here. All right. So how many cubes now can I fit in here? 3 along that way, 6 along that way, and then 1, 2, 3 for my height, and then 1, let's see, this is 1 inch cube, so I can fit 2 more in there and 2 more in there. That's kind of messy. Let's do it this way. I can fit 3 cubes within that 1 cube height. Here's another cube of height, but I can fit 3 in there. Then in this top cube, I can fit 3 in there. So for every 1 cube, I'm fitting 3 more, so that makes my height equal to 9. So my bottom layer is 3 by 6, and my number of layers is 9. And that's going to be, I believe, 162. And that's how many 1/3 inch cubes I can fit in there. And I wonder what the multiple is for that. Well, notice that because I'm using 1/3 inch cubes, I'm multiplying my original dimensions by 3 each time. So just like we did in the last one, I have 3 times 1 and 3 times 2 and 3 times 3. These 3 give us our original 6, but then using 1/3 inch cubes brings this extra dimension of 3 times 3 times 3, and that gives me 27. And guess what 6 times 27 is? 162. So we're multiplying by 27, which is really the same as saying multiplying by 3 cubed. All right, so these were kind of tricky. Let me know if you have any questions, and we're going to have an exit card after this, and then you can start on the homework.